It finally happened over 10 years since our last remote code execution vulnerability came out in WordPress core. That was all the way back in WordPress 3.12, arbitrary file upload, way back in May of 2011. Okay, so this was what, 15 years ago, and this vulnerability didn't even have the attack vectors leaked. I don't know if any exploit code was ever produced. But here in the AI era, with GPT 5.6 Sol Ultra, a security researcher in Australia has given us WP2Shell, okay, an obvious analog to the log4shell vulnerability that was released back in 2001 that caused so much havoc in the Java community. We now have WordPress to shell in the default install. Now, how this vulnerability works is it chains a confused deputy mismatch that has a validation for an API request, process for one API request, and it has the handler process for a different request. So you're able to send a bulk request with two different actions, or in this case, and I think the actual exploit uses 6. And because of the mismatch, the validation code runs for one of those requests, and the actual handler happens for a different request, allowing that handler to bypass the validation, allowing us to hit the SQL injection and exploit the SQL injection because the filtering never ran. That SQL injection code then just returns a post. But the power and the magic of AI has found a pop chain that allows it to return a post with a change set, with the change date set in the past, causing WordPress to update the post as the user who updated it. And since that entire fake post that was created through the SQL injection is controlled by the attacker, it's the change set has the user ID set to the local administrator or user ID 1. That causes the save to run as the administrative user. So WordPress impersonates the administrative user, causes the save to run. The save calls a callback handler at the very end, notifying plugins and themes that this post has been updated. But because the attacker controls the name of the callback handler, it changes the callback handler to be the reprocess the request callback, causing the entire request to be processed over again, but this time as the local administrator. The last request, or the last API request inside that bulk request packet says to create a new administrative account. And since the entire request is being processed as the local administrator, due to the SQL injection pop chain, the request to add the local administrator succeeds, and an attacker is able to add a local network administrator account to your site, upload a backdoor plugin, and execute any code on your server on the default install. The pop chain is amazing. I didn't even do it justice. There's actually a nested chain of 6 different posts that have to be embedded, referencing each other to call embed links to cause this entire pop chain to unfold. It's the most wild pop chain I've ever seen. We're definitely living in a different era in the AI era. So in this video, I'm going to show you what the exploit looks like, how to run it, where to get it. It's been out for 5 days. It's on GitHub. WordPress has pushed force updates to all vulnerable versions. So unless your WordPress install specifically has held back WordPress core updates, okay, which is a setting you can add to your WP setting file, unless you've enabled that setting, you've already been patched. If you haven't enabled that setting, you've already been hacked, because every website I've seen is receiving about 6 to 12 attack attempts per day. So you're definitely compromised. This is huge. This is the biggest security vulnerability I've seen in the WordPress community in the time I've been affiliated with WordPress. I've been doing computer security for over 25 years. I got started back in the 1990s. And this one is definitely like probably top 5. So big credit to Searchlight Cyber for finding the security vulnerability. Let's go ahead and show you our demo code now. So this is our demo install. I've installed 2 security plugins. I've installed BitFire so that way we can see the security logging for our site. BitFire has a nice log where we can track all the requests. So here we're running the free version of WordFence. Now the free version has those rules delayed by 30 days. So none of the free users will be getting protection from this vulnerability until somewhere around August 15th, August 17th, something like that. By that time, your site's already been compromised. Like I said, I'm seeing 10 different attacks against all sites that I manage per day. So if you're not patched right now, you're currently vulnerable and you've definitely already been hacked if you're connected to the internet. Now, in order to observe this exploit, we're going to use BitFire as a dashboard. BitFire contains a request log right here. So we're going to run the exploit and we can see all the requests here in the dashboard. So this is the root directory of our vulnerable server. This is our exploit code. This is freely available. You can search Google. You're going to find this particular exploit code. It's on GitHub. There's 5 or 6 different versions. There's new ones being uploaded all the time. This is nothing new. I'm just going to show you right now. This particular exploit is going to create an interactive shell on our vulnerable server. And it's going to be a shell that allows us to do anything. Upload PHP scripts, upload malware, inject posts. We're going to have an administrator account. We'll have a complete site compromise. So it runs pretty quick. We're going to go ahead and kick it off, and it has a couple little handy messages here. And yeah, it's vulnerable. And if we go over here to our server, we can see these are the requests that it's sent. So it's about a dozen different requests, and it's all to that batch API. And what it's doing is it's creating the confused deputy problem, and then it's injecting the post, causing that post to be updated. That post is updated as administrative user, causing the request, this bulk request with a bunch of different actions in it, to be processed again. And that last action is to create an administrative user that runs as the admin account. I'm going to do a technical walkthrough after I show this exploit. And here's our last action. It hits plugin install and uploads the shell, and everything returned HTTP 200. None of the requests were blocked. Deploying web shell plugin, and there we go. Who am I? www.data. I'm the www.data user. We can change to user local fresh. And this is our directory, but it's running on our attack machine. Now we can come over here and we can drop a dropper here in our root directory. So all this did was we used the echo command to write this exploit.php script. And if we do a directory listing, there's now exploit.php. And we can use that to write anything to the file system now. Exploit.php. And we're going to write, let's write this. Okay, so I just wrote the script hacked to hacked.html. So now if I go to my website and I view hacked.html, we can see the website is hacked, right? And if we look at the root directory, there's our hack.html. We can modify any script. We can basically do anything we want to. Let's exit out of that. Now we're back on our temp py server. We'll go ahead and clear the directory. Now let me show you how to protect yourself from this vulnerability. So we're going to go ahead and delete this admin account. We're going to delete all content. We are going to go to the plugin section, and we're going to delete those 2 backdoor shells that we just created. Now everything's set up. If you are running WordPress and you're running the free version, you will get signatures sometime around middle of August. If you're running the pro version of the $150 or $900 version, you already got patches for this. So you're already protected. Those went out on July 17th, according to WordFence's information. Now, that's our attack chain. This is what it looks like when it's not blocked. Okay, so this is the entire attack chain uploading the backdoor, doing the login, creating the administrative user. Let's go ahead. Right now, BitFire has no settings enabled. We're going to go ahead and enable one setting. In the runtime application self-protection, we're going to turn on login and account protection. What this does is anytime WordPress takes an action as an administrative user, it's going to look at the request and see, does this user have a valid login cookie? Have they authenticated using an application password? Is there any authentication information provided at all? And if the request takes any action as the admin user without providing valid credentials, it's going to get blocked. So now that we have that RASP setting enabled, let's go back and we're going to run the exploit again. Now it's important to note here that this is not a patch. This is not a patch just for this vulnerability. This protection was already baked into BitFire years ago. We've been running this protection for years. This protection mechanism protects you not just from this vulnerability, but zero-day vulnerabilities going into the future, whether or not they're reported by security researchers, or whether or not they're exploited by hackers before WordFence or Cloudflare or Security or any of the other security vendors have time to release and create patches. It's a completely different approach to web security. That's our first way of blocking it. That's for our pro users. This is blocking the exact function that's being executed. Doesn't matter how. It's not looking at the request. It's looking at what the request is doing and blocking it. But for our free users, right, if we turn that off and we run again, right, this is going to succeed. Now for our free users, we have a web application firewall. And the web application firewall, yeah, there we go. This uploads a plugin, deploying the web shell. When we turn that setting off, it works again, right? ID. Okay. So for our free users, we have our web application firewall. Now this is going to trigger, because the exploit is attempting to use a less than character, right, which is an HTML tag, which is included in the post, but they try and escape it with UU encoding. So it does a UU encoded version. Now the firewall is going to see that in the exploit, and it's going to trigger on that and block it as a cross-site scripting attack. Even though it's SQL injection, it's actually blocking the cross-site scripting in the SQL injection. If that rule didn't fire, the SQL injection rule would have fired. Let's go ahead and test that one. And you'll see this time it's blocked in a different way, right? Now it's blocked at a different level. And if we go back to our dashboard, we can see here's our blocked request. Here's our first one. This was blocked because the RASP authentication failed. So this was the step that tried to create that administrative user, and that request was blocked right here, right? RASP authentication failed. Block code 47001. Now you notice here it says fake browser. Now the reason it says that is because this is reporting itself as a web browser, Chrome version 126, but it hasn't authenticated itself. Every page view when you're running BitFire until the browser authenticates itself adds a tiny bit of JavaScript that requires the browser to verify itself. It has to run that JavaScript and send back an authentication code. Bots don't ever run that. They don't run JavaScript. They don't execute code like a normal browser does. So they'll always show up in here as fake browser. Okay. Now we can use that to implement bot blocking to also prevent this request. So let's take a look. Here's our other one. This blocked with rule 10104, cross-site scripting. And I can show you the exact part of the code that was blocked. If we go back to our vulnerable server here, and we can see there's our new files we just dropped. But I added over here when I was going through this exploit code, and here is what's being blocked right here, this U003C. Okay. This is trying to inject a caret symbol, and it's trying to hide it as a UU encoded greater than symbol. And we also have, well, this is actually a less than. This one right here is a greater than 3E. Pretty sure I have that correctly. That's what's being blocked by the WAF. Okay. So that's the second way we can block it. If we go back to settings, right, we can turn off the WAF. We can turn off the RASP functionality. Again, this is not blocking based on what the request looks like. This is blocking based on what the request is doing. That's how we're able to stop zero-day attacks, attacks we've never seen before. And this time we're going to enable two features: require full browser and restrict bot access. Require full browser says anything that says it's a browser has to submit that validation JavaScript in order to post any data or alter anything on the server, right? So any API endpoints that alter data, change data, manipulate anything, those have to be validated. And any bots, right? Anything that says, hey, I'm Googlebot or BingBot, those have to validate themselves as being authentic before they can post data to the server, okay? So if now that we've enabled the bot protection, we can go back to our exploit. Let's go ahead and, well, we'll just leave that up there. We'll run it again. And this time we fail much faster, right? The auth admin creation failed, right? So the fake primitive and post not available. It's kind of a misleading error message. If we go back to the dashboard, we can see that the very first request was blocked because the batch API is a restricted API that allows you to modify data. And this, when bot blocking is enabled, you can only hit API endpoints or requests that modify data after you've verified you're a good bot or after you've verified that you can run JavaScript. So that's why this request was blocked. So that's 3 different blocking methods for this exploit. Both of the free versions can be bypassed. Bot blocking can be bypassed by getting a valid JavaScript authentication code and sending that to your exploit, or by modifying the exploit code to bypass the UU encoded character. Either one of those would be bypassed. This is a default proof of concept exploit, so the free version is going to stop most of that. If you care about your website, if you have an important website, only the RASP version, which is our pro version, contains that RASP code that actually looks at what the request is doing and stops it regardless of what the request looks like. So let's go ahead and take a look now at exactly how this works. This exploit's completely wild. This is one of the craziest exploits and pop chains I've ever seen. This is a very simplified version of this pop chain. Go read the description linked in the, or go read the blog post linked in the description below. I have a link to the WP2Shell blog post that the author created, which is a little more detailed than mine. There's actually 6 different posts that have to get injected through our SQL injection with cache poisoning to create and actually go through the convoluted chain to execute this exploit. It's completely wild, but I'm going to give you the short version. This is based on research I did yesterday. So this is the SQL injection. This is the actual vulnerable code. And there's this query vars, which are the input parameters to this API function that basically just loads a post. That's all this thing's doing. It's just loading a post. And it has filters. You can say load the post for this user, load the post for this category, different things like that. One of the things you can say is load all the posts where the author is not this author. And that takes a list of user IDs, of author IDs. Now, if that list is an array, then it does this encoding that makes it safe for SQL injection, makes it safe from SQL injection, right? It calls the absolute integer function, right? Basically just casts everything to an int. So if you put in some big union SQL statement with a bunch of crazy SQL injection, that's all going to get converted to just a single number, and that's not going to be valid SQL injection, so it's going to fail, right? Your exploit's going to fail. This code has to be bypassed. It can easily be bypassed by not sending a list of user IDs, but by sending just a plain SQL injection. So if you don't send an array, this runs to this line of code right here, which if it's not an array, simply just passes it right into this where clause of our SQL statement. So if you don't send an array, it doesn't do any filtering, and it just gets passed right on into the SQL query and the SQL injection. Now, normally that would be fine, but in front of this API request, there's an additional filtering layer that makes sure that all the input parameters are of the correct type. So it won't, that filtering layer won't allow you to pass in something that's not an array to this variable right here. That's where the second CVE vulnerability comes in. This is a confused deputy problem. It's not really a deputy. It's more like an array mismatch issue. But I'm going to try and run through this a little quickly to get through exactly how this works. Basically, you have the batch request because we're hitting that bulk API endpoint. It has multiple request actions to do. And for each one, it's going to parse the URL of the action to perform. Now, if that parse fails, we're going to create a new WordPress error, and we're going to add it to this request array. Okay? Parse failed. Hey, that's an error. Make a request, call it an error. Parse didn't fail. That's a good WordPress REST request. Add that to the request. So after this function right here runs, right, and this is just snippets that I pulled out of the original code. After this code right here runs, requests is an array or a list of either REST requests or errors, right? Requests can be, that's going to be errors and requests together. Now, we're going to split that up into validations, right? The validation list, whether or not the validation passed, and matches. Matches is the event to go pass, right? The event handler to go send this request to. Well, if it's a WordPress error, right? If the request we're looking at is a WordPress error, add it to the validation errors and keep going. Now, if it's not a WordPress error, add it to the list of matches and keep going. Now we have two different arrays, validation errors and matches. Those are two different arrays with two different indexes and two different list sizes. We have one validation error, validation has one entry, and matches could have 10, 20, or any number of entries. Now, this is the vulnerable code right here. We're going to loop over the requests, right? This is our initial request we created here. That's the request that can be either the request object or the errors. We're going to say, hey, is that an error? Oh, I'm sorry, we skipped that one. We're going to say, hey, is that an error? Just skip it. But we've consumed an index, right? Because requests is a list of both, and matches contains a list of only the non-validation errors. If anything in request has validation errors, that request is going to map to a different handler. So what this allows us to do is send the validation for our request, right? Remember, we have this author not in parameter that we want to not be an array, but the associated API endpoint validates that it is an array. Well, now when we're down here, we can match any event handler to any validation point. So we send two requests, one that has an endpoint that will allow that validation to pass, the SQL injection to pass, or just anything that's not an array. It's not looking for SQL injection. It's just checking if that's an array. And then we're going to pass it off to the next handler, which is the handler for our vulnerable injection. And it's going to bypass that is array check. So that's how we have those two different arrays. They get out of sync. It thinks that the validation for one ran, and it's going to hand that validated request for one event handler to a different event handler. That's how we're able to bypass the other layer of protection and hit the SQL injection. So you think, well, this SQL injection's only for a read post. It only allows us to read post data, right? We can select posts. How could that create remote code execution? Well, that is where things get interesting. Let's go over here, and we're going to look at our let's look at how this works. So when it loads, this is a greatly simplified version. The actual vulnerability contains 6 nested posts, each with embed links, referencing the other ones that create this valid pop chain. This is going to be just a simplified version. Basically, we load a post that has a change set for a date in the past. Now, normally you'd create this change set for a timestamp in the future and say, hey, at this time, run these changes on this post. Well, because the time's in the past, it's going to run immediately. That change set says, hey, just change this field like, the title to anything, whatever. And the user who changed it is the administrative user, because every change has an associated user. And what WordPress is going to do is it's going to call this code right here, WP set current user, as the user ID. Well, because we can control that post, right? We're SQL injecting a post that we can control. We can essentially read a post out of the database that does anything. We can put anything we want to in there. So we say, well, we want a change set that was created by the administrative user, and it changes the blog post title to whatever. Now, WordPress says, hey, I better save that. First, I'm going to change the user to the user who made this change. Then I'm going to save it. That's fine. It changes the title. That's not the end of the world. But normally, after that save runs, it calls an event handler. It says, hey, I updated the post. I updated this post to a published blog, right? I changed the status to publish, and it's a type of blog. And run the event handler. Let all the plugins and themes know that we've published a blog post, and they can do something with that. But because we can control this variable right here, this new status and post type, we can control the action that gets called. So in the exploit code, we call parse request. Parse request says reparse the entire API request. But now, because we're running inside this save handler as the administrative user, it's going to run that request as the administrative user. And because it's the bulk API endpoint, we can put as many requests in there. And the last request in the exploit chain adds a create administrative user with a default password. And then it says, yep, you're authorized to do that. And it creates an administrative user. And now you've added an administrative user onto your WordPress site that's controlled by the attacker. They then upload a plugin that is a backdoor, and they have full control over your system. It's a really ingenious, crazy pop chain. I've never seen anything this wild before, ever. And you're getting to like some shadow brokers, NSA, Stuxnet kind of vulnerabilities now with this stuff. And this was found in 6 hours using GPT-5.6 Sol Ultra mode. Absolutely wild stuff. So if you want to be protected from vulnerabilities like this in the future, I recommend a plugin like BitFire. BitFire has 0-day protection. We rarely release updates. The system contains authentication systems inside of WordPress looking for the crosses those trust boundaries. One of our other ones actually inspects every file write at the file system layer, not inside PHP, not inside WordPress, but the PHP file system layer, and can prevent any file writes. Like, actually, let me show you that right now. We'll go over here to settings, and we'll enable file protection, and we're going to need to make sure always on is enabled, because the script that we're going to be running is not part of the WordPress startup chain. WordPress isn't going to load. The plugin's not going to load. We have to have that always on protection enabled. And then we're going to come down here. We're going to make sure file protection is enabled. Exactly. And you remember, let's see, where was it? This guy right here, this script that we wrote, right? This is our loader that allows us to write anything we want to. Well, let's look over here. And what we have in our root directory is our exploit code, and there's our hacked file we wrote. And we have this hacked PHP, which is this HTML. We can get rid of that one. Now, what I'm going to show you is from our attack box here, we're going to say, hey, write foo.php with text anything. Actually, before that, let me show you how it works. We'll write a text file. We get nothing back, and if we look on our server, there's our foo text file, and it says anything. But what happens if we try to write the same thing to file PHP? Well, we get this nice error page. Runtime application self-protection. PHP file locking was blocked. And if you look at the script, all it does is this right here. This is literally the most vulnerable piece of PHP code you could possibly write. It's the most simple loader. It's running on the system. And BitFire is able to intercept that request and tell that it's trying to write to this script. Now watch this. If I say, let's edit that exploit, and instead of that, let's just comment this line of code out, just to show you that this is actually running. Let's comment that out. Go ahead and write it. And let's run our exploit again. And there's no error, right? It wasn't blocked because it's actually intercepting that file write request and preventing it. So that's just some of the functionality that our RASP layer has. This is all 0-day protection. These aren't special rules. These aren't special patches. This is built-in protection into the system. Go check it out. It's at bitfire.com. I hope you guys learned something from this video. Please drop a comment. If you have any questions about BitFire, email support@bitfire.co. We always help out our customers and clients and make sure that their sites are running as smoothly as possible. If you have any issues enabling BitFire security, just send us an email. We'll get right back to you. Hope you guys have a great day. This exploit is crazy. This is totally nuts.